Welcome to the newcomers. For those who are coming back, welcome back to my YouTube channel. It's Rishi, and this is the part 2 video for Form 3, Chapter 2, Standard Form. If you have not watched the first video, I would highly recommend you to watch it before continuing with this video. So, without any further ado, let's get started. Now, we are going to take a look at standard form. This video has two parts to it. First part is we're going to learn about what is standard form, and then we are going to see two different questions that you can be asked, which are normal questions and tricky questions. So we're going to see them one by one. So let's begin. So first off, what is it? Take Earth as an example. So Earth is our planet, and the closest star to our planet is the sun. And the distance between the sun and the earth is roughly 150 million kilometers. If we were to write it in numbers, it would be 150, 1, 2, 3, 4, 5, 6 kilometers. We will have 7 zeros to represent the distance between the sun and the earth. And remember, this is the number just for our closest sun. Imagine when we have to calculate the distance between two galaxies or two universes. Well, that's a multiverse theory. Let's not go into that. So, what standard form does is that it allows us to represent this huge number in a short form way, or we can call it in an abbreviated form. For example, this exact number can be written down as 1.5, 10 to the power of 8. So we have looked at the big example where the distance between the sun and the earth is humongous, but there's also another way standard form is used. Standard form is also used to calculate the length of microorganisms. So as we know, microorganisms, as their name suggests, micro, they are incredibly small, incredibly tiny. And for these numbers, instead of having a lot of zeros at the back, they will have a lot of zeros at the front. For example, the numbers can be 0.0000000 to 5 meters or centimeters or millimeters. We usually use the unit micro, but this is just an example. So when we have so many zeros, at one point it can get confusing. So here, this exact number, 0.0 of 1, 2, 3, 4, 5, 6, 7 zeros, followed by 2, 5, can be written down as 2.5 times 10 to the power of negative 8 meters. 2, 3, 4, 5, 6, 7, 8. Yes, that's correct. 2.5 times 10 to the power of negative 8 meters. This is the power of standard form. This might not seem like a lot in the beginning, but as you go deeper into any scientific field or any astronomical field, you'll start to notice that the numbers get very big very fast. So if you have 9 digits or 8 digits, it's still possible to write down the entire figure. But imagine if the digits go up to 100, 200, 300. I'm not kidding you, it can go that far. When it goes that far, it is not realistic to write down all the numbers, all the digits. That's where standard that's where standard form comes in handy. Now, before we start using standard form, we have to know how to use it first. There are just two rules. First rule is that standard form in form 2, what we are learning would only comprise of 10 to the power of something. So we are using 10 to represent the numbers that have a lots and lots of digits. So for instance, if we say 2.5 times 10 to the power of 4, What we are meaning is we're going to write 2.5 and we are going to move the decimal points 4 places to the right. 1, 2, 3, and 4. So we'll have 25,000. So 2.5 times 10 to the power of 4 is equivalent to 25,000. So that's the first rule. You must always use 10. All right. Now, the second rule, this rule is very important. People do forget this sometimes, is that the first number, the digit you're writing over here, right here, this one, it has to be it has to start from 1 and must be more than 1 and less than 10. So if you were to represent the number with the letter A, it has to be more than 1, but it can be 1 and more than 1, but it must be less than 10. So that's why we are using 2.5 instead of 25 or 250 or 0.25. It has to be between the numbers 1 and 10. So if you have both of these down, it's going to be incredibly simple. So before we go to the questions, it's important to understand one more thing. This is something we learned in primary school, but I'm here to refresh your memory so that we are on the right track to solving the questions. What is the refresher? Let me tell you. When you have divide 10, what happens to the decimal point? Some of us will remember this, but some of us might have forgotten how this works. So just a refresher. So for divide, what you have to do is bring the decimal to the front. So for times, what you do is bring the decimal, bring the decimal to the right. So when you divide 2.5 by 10, you will get 0.25. On the other hand, when you times 2.5 by 10, you will get 25. It's as simple as that. This is crucial for you to understand so that we will be able to progress with the other questions. Okay, now that we have this understanding, let's drill in with some easy questions. Let's go. So here, let's say that the question gives you a number 0.00049 and you are asked to represent this long decimal number in the form of in a standard form. So what would you do? I'm going to give you 3 seconds. If you need more time, feel free to pause at any point. So 1, 2, 3. So what you would do is you would see how many decimal places does it have to move in order for you to get a number that is more than 1 or less than 10. So what I would do is I would just bring the point 1, 2, 3, 4 till I get to the point where there is one number on the left, one non-zero number on the left, one non-zero number on the left, and I will stop right there. So here we have 4, which is non-zero number, and we're going to put 4.9. So remember, since this decimal point is actually going to move forward to get this decimal, we have to write times 10 to the power of, so calculate how many points are there. 1, 2, 3, and 4. So the decimal point has moved 4 places. So we're going to write -4. Remember, it is moving forward. The point will be moving forward. All right. Please do not get confused that this point is moving backward, so it has to be times, it has to be positive number or negative number. No, please don't get confused. So what you have to do is remember this. You have 4.9, correct? Okay. So for 4.9 to have more zeros, you'll have to times 10 with the positive number, 10 to the power of a positive number. On when it so On the other way around, if you're going to move the decimal point forward, you have to times this by a negative number. All right. If you do not understand this part, I would recommend you to watch my videos on indices and how does index works. Because 10 to the power of negative 5 essentially means 1 over 10 to the power of 5. You are actually dividing the number. That's why it's moving forward. That's what I referred to earlier as divide. So divide 10 and times 10 to the power of negative 1 are both essentially the same. So it's important for you to understand this. So when we did this, where we went from decimal number to 4.9, we were reverse engineering this. So if even though this is going backwards, we are actually saying how do the decimal point move from 4.9 to 0.00049. We are reverse engineering how it works. I'll give you one more example. Let's say there is a number 490,000. Okay, we're going to use the same two numbers, 4 and 9, the same thing. So here you cannot see decimal point. So that means there is a decimal point at the end of the number right here. Every whole number has a decimal point at the back. It's invisible. That's how I remember it. So here what we have to do is, let's see how many places does the point have to go in order to become a number less than 10 but more than 1. The same concept on the left hand side of the decimal point, that has to be one non-zero number. So again, let's go 1, 2, 3, 4, and 5. So 4.9. So you will have 4.9 and times 10 to the power of 1, 2, 3, 4, 5. So it's 5. It's positive or negative? Now that's the question. So what we have to do is, do not see from here. Please see from here. So for 4.9 to become 490,000, it has to undergo multiplication. If it gets divided, the point will move forward. So always look from here. Do not look from here, because looking from here might confuse you big time. So that's why I always go from the smallest number, 4.9. Smallest as in the number of digits. When the number has more digits like 0.00049 or 490,000, lots of zeros will definitely make your life much harder. So just try to go from here and be like, okay, 4.9 times 10 to the power of 5 or negative 5. Oh, okay. If it's negative 5, the point will move forward, causing it to become decimal, causing it to become a long decimal number. But the number given is not, that doesn't even have a decimal point. So we have to times by a positive 5 so that it goes back. That's how you should do it. If you cannot understand this part, I would recommend you to watch it one more time just for clarification. And if you still can't understand, send me an email or send me an email, or feel free to comment in the comment box below so that I will be able to help you there. If you're commenting, make sure you tell me which part of the working stat that is confusing to you, so that I will be able to laser focus and explain that part to you easily. Explain that part to you in detail. So this is the basic understanding. This part is where you have to have a very good understanding of indices. Okay, so let's move on. So the first type of question, normal questions. By normal, I mean the numbers that you have to do arithmetic. So this is arithmetic, by the way, arithmetic. You have plus, minus, times, and divide, but mostly plus and minus. So divide and times will not be a major thing here. So plus and minus, this is normal because you'll have the same 10 to the power of something. That will be the same. The x will be the same. For instance, you will have 2.5 times 10 to the power of 7 plus 4.9 times 10 to the power of 7. Since the power is same, you do not have to worry about anything. You can just straight away go on with adding these two together. If you're wondering how come I can do this, because this follows the laws that you learned for algebra, which is you can factorize them. If you factorize 10 power of 7 out, you'll have 10 to the power of 7 outside times 2.5 plus 4.9. It's as simple as that. It's the same concept, exactly same concept. 2.5 plus 4.9, you will get 10 to the power of 7 times 7.4. So if you write it in the in a standard form, would be 7.4 times 10 to the power of 7. As easy as that. Let's do one more example. For instance, you have the number 8.6 times 10 to the power of 7. Let's change it. Let's say 8 plus 8.4 times 10 to the power of 8. Same concept applies here. If you want to take out 10 to the power of 8, it's completely up to you. So let's do it. 8.6 plus 8.4. For this question, let's keep the 10 to the power of 8 at the back because it doesn't make a difference. 8.6 plus 8.4, you will get 17.0 times 10 to the power of 8. Remember the law. The law states that it has to be a number less than 10 but more than 1. 17 is obviously more than 10. So what we have to do here is move the decimal point forward and you will get 1.7. Okay, 1.7. And then you think, oh, okay, so for me to get 17 from 1.7, I have to times it by 10 to the power of 1. Correct. Times 10 to the power of 1. All right. Now is where you times 10 to the power of 8 at the back. All right. Okay. So what we learned from our chapter 1 is chapter 1 indices is that when the same base number times by itself, its powers will be added up together, will be summed up together. So we have 1 here and we have 8 here. Together they make up 9. So what the answer for this will be 1.7 times 10 to the power of 9. That's it. This is where it can get tricky a bit because you will have to remember the law. It has to be less than 10 but more than 1. This is why it's important for you to understand this before moving on to arithmetic. So we did plus here. In the event that you have minus, it's going to be exactly same. There is no difference. Just minus as usual. But make sure that it is more than 1 but less than 10. All right. This is the first type of question. Normal questions where you have the same 10 to the power of x, where x will be the same. Okay. Now, this is where we are going to take a look at the tricky part, the second type, where you will have different 10 to the power of x. The power of 10 will be different. Let's take a look. 2.5 times 10 to the power of 5. Here, you'll have 4.2 times 10 to the power of 4. This is where it gets a bit tricky because to factorize a number, it's important for you to have the same power. 10 to the power of 5 times the power of 4. They are both different. Okay, there are different approaches to this. If your way works, just follow your method. I'm going to show you a method that is correct, that's definitely correct, and it's much easier. It kind of resonates with your textbook, but not 100%. So what we do here is we take out 10 to the power of 4 or 5. Here we'll take it down to the power of 4 because 4 is much smaller. So what I would do is I would factorize out 10 to the power of 4. So when we take out 10 to the power of 4 from this part, 10 to the power of 4 outside, so you will have 2.5 times 10, okay, times 10, and you will have plus 4.2 times 1. Do you see that? I took out 10 to the power of 4 from both sides. So I have 10 to the power of 4 here, 10 to the power of 4 outside, and 10 inside. And we have 4.2 here and 1 here. All right. Okay, do you see that? And then what I would do is I would solve this. 2.5 times 10, you will get 25. So we'll get 25 plus 4.2 times 1 is 4.2. So we will get 25 plus 4.2, which is solvable. So 10 to the power of 4. 25 plus 4.2, you will get the answer 29.2, which can be written as 29.2 times 10 to the power of 4. Again, remember the law. Has to be more than 1 but less than 10. 29 is obviously more than 10. So what we're going to do is we're going to move it here. First, move the point until you get a single digit on the left hand side of the decimal. Single digit which is non-zero. So you have 2.92. After getting 2.92, see how you can revert back to 29.2. How? By multiplying by 10 to the power of 1, because there's just 1 here, just one place here. So it's going to be 10 to the power of 1, and just add this 10 to the power of 4 at the back, so times 10 to the power of 4. So same base, the powers can be added up together, which means you'll get 2.92 times 10 to the power of 5. That's it, as simple as that. Now let's try it with negative numbers. 4.7 times 10 to the power of negative 4. And then let's use minus here. So minus 2.5 times 10 to the power of negative 5. So we have different numbers. So what we're going to do here is what we're going to do here is the exact same thing. We're going to factorize the smaller number. So 10 to the power of negative 4 and negative 5. Which one is smaller? Negative 4, negative 5. This is where it might get a bit tricky. I would not recommend you to use the exact same method that we used for the first one. This is what I use commonly for positive integers, because it's much easier to see what goes where. But for negative integers, things can be a bit tricky. So what I would do here is, this is where I would just follow the textbook working steps. 4.7 times 10 to the power of negative 4. Okay. Here, instinctually, we know that 10 to the power of negative 5 is just 10 to the power of negative 4 times 10 to the power of negative 1. Okay, let that sink in. Negative 4 plus negative 1 will get you negative 5. Do you see that? Okay. So with that knowledge, we have broken down negative 5 into two parts. Okay. Now we have got a negative 4 on both sides, and what is disturbing the entire equation from progressing forth is this part. So what we can do is we can just take 2.5 and multiply it by 10 to the power of negative 1. That's it. So at the front, you will still have 4.7 times 10 to the power of negative 4 minus 2.5 times 10 to the power of negative 1 will get you the answer of 1 over 4 or 0.25. You're just moving the decimal point one step forward. So we get 0.25 times 10 to the power of negative 4. Now we have gotten to the similar question as type 1, where we have the same base. So here will be 4.7 minus 0.25 Outside will be times 10 to the power of negative 4. So 4.7 times 4.7 minus 0.5 will get you the answer of 4.45 times 10 to the power of negative 4. And since this number 4.45 is less than 10 but more than 1, we are done with the question. That's it. So these are the two ways to do the question. For positive integers, I would recommend you to use this method because it's much easier to see this if you understand index. Understanding index is important for this working step. If at all you are unable to do this, it's okay. You can still break down the number into two parts, one part being the same as the other power, so that you'll be able to factorize them at the end. Any parts that you can't understand, try to watch one more time. But if you still can't understand, please raise your questions to me through email or through the comment section so that I will be able to attend to it in detail. With that, we have come to the end of this video. Do not worry if you can't understand any parts of today's videos. It's important that you understand the gist of it, and your knowledge of application will become better when you see me doing the questions in the next video. So till then, signing off, it's Rishi, and catch you in the next one. Bye bye.